Today I will take you through a diffraction experiment using Snell's law. To keep everything focused and to guide you through my video, I provided a table of contents. First we'll start with the history, then we'll move into Snell's law, and then the experiment, and I'll go over the theory, and finally I'll go over optimization and improvement. Wilbord Snell van Rooyen. He was a Dutch astronomer and mathematician who was born in June 13, 1580, and he died October 30th, 1626. He was most known for creating Snell's law, and it pretty much states that the ratio of the sines of angles of incidence and refraction of a wave are constant when it passes through two given media. We use Snell's law to find the angle of incidence or the angle of refraction using these ratios shown above. You see that n1, which is the medium, multiplied by the sine of the angle is equal to n2 of the other medium times the angle of that. Light travels along straight line paths, but what happens when light enters one transparent medium to another? Does it still move along a straight line path? Observe carefully at this experiment that I will take you through. Do you see it? Notice how my arm is going the complete opposite direction, and notice how the pencil looks like it's shifted a little bit. Again, notice how the arrow is completely flipped in the complete opposite direction. Is the pencil and the arrow actually flipping? Or is the pencil actually bent? No. What's happening is the speed of light is actually different through water or air. So the light coming out of one end of the pencil in the water is changing its direction when it's coming out into the air. This phenomenon of bending of light at the interface of two media is commonly known as the refraction of light. The extent of the change in direction that takes place in a given pair of media is dependent on the refractive index of the two media. So using Snell's law, we can calculate the index of refraction and see how much the angle is changing and see how much the shift or difference in image is going to be. Now that we know how it works, I would like to go over optimizations and improvement and wrap up this video. I think I could have made it better by using different shaped glasses, and I could use different objects, such as lasers. Well, that's all for me, folks. I hope you had a good time.